Reviewing the general insurance company data, and they purchase this data and want to see if we can find some insights in this data. So first of all, we have to import all our necessary libraries, importing this to be able to see all the columns, because it's a lot of columns in here as well as rows, to be able to analyze it and view it. So second of all, we are importing of all our data sets, all our links, and getting ready to do the data preparation for this Abilitech 2 data. So we are trying to exclude all the objects because the object doesn't mean anything in cluster analysis. So we have to get rid of it and only have the numbers. So we are dropping this data types, and now we have to get rid of our zip codes because they don't matter for us either, so we have to drop them. Now we have to check the names of all the columns and presented in Abilitech data, put all our name columns of Abilitech data into new data frame, and which shows only the names and the columns, names of the columns. And now by selecting the key phrases in our columns, we are creating a couple of different data frames for each specific name. So then we concatenate all our names of the columns and make one list of all the columns for our DFAP2 list. So I was selecting mostly financial data and I was focusing on mostly that information. So now we have to select all columns from the Abilitech data and add our original data with our final data. So now it looks like that. So it looks like we still have object, and we have to get rid of it from this column, and also we have to get rid of all the null values. So we are dropping this column, we get rid of all the our nulls. Now we have to do our cluster analysis because all our data is ready. So we are creating an inertia model, and we are running this inertia model to see how many clusters are ideal. And it looks like the number 4 clusters would be good in this situation. So we are setting the number of the clusters, feeding the model, and for our predicting, we're creating the data frame and then concatenating our cluster results to our original data frame. So looks like the cluster number 1 is our main customer, and it looks like it's a really good customer. So we're gonna focus on this specific cluster and see what insights we can find because how we can bring our more customers, how we can do any specials to keep these customers and stuff like that. So by looking at all this data, I have checked the columns that have used credit card, and cluster number 1 is the highest mean number out of all the clusters, meaning our average customer use credit card very often. We can offer some specials for credit cards users, like setting automated payment and get discounts on a policy and stuff like that. So also we can maybe do some collaboration with a bank if they make let's say if they're gonna do like a cashback for some of our transactions, we can bring more customers that way as well. Also, I looked at the columns where it has mortgage or personal or joint mortgage or loan or finance equity loan for the house, which means they own a home, and we can target that group as on upselling our home insurance, and it's going to bring the lifetime value of our customers up. Also, by looking at the data have paid bills by different ways, we can assume that our customers is not very digitalized. Maybe we can target those people not with just regular emails, but also with letters, cards, or some specials in newspapers, magazine, and stuff like that. Also, by looking at their contribution to charities, cluster number 1 was the highest, and maybe we can do some campaign that can take percentage or part of the resources from the policies that will be donated to some charities. They can bring more customers that way. Also, looks like this group often has a business, as they have a biggest amount of business cards in this cluster. Maybe we can come up with some business insurance deals to increase again the lifetime value of such a good customers. I think this group loves in-person experience. So like I noticed that they love to go to bank, they love to get their taxes done by actual person, actual accountant, not just through online services. And most of the insurance companies, they do work online most of the time through the phone. And I feel like if General can open a location where people can really come and sit with a person and have customer service and support from in-person communication, they trust providers more that way, I feel like. And that's pretty much it. It looks like we can also might add some data about their age or salary, because I looked at this and it looks like it's older range of the people, because they love to invest. They're very financially stable. Probably they have high salaries, and they are a very loyal group of customers, and they tend to stay with their providers. Looks like their data showing us that they didn't change often, so that's good. So okay, let's move on to modeling for predicting quoted total payment. So we trying to predict how much we should quote our customers. This is our y variable. So first of all, we have to clean our data again, get rid of the object, transfer some, change the object to numbers by using label encoder. And looks like our data is ready, so we can predict. We can define x and y variables, so which is x will be everything else besides quoted total payment, and y will be quoted total payment. We are running a function to find the best alpha value to use, and it looks like it's 5 here because it's dropping after it, so we're gonna use 5. We are running our accuracy score. It looks like it's okay, but not the best. Okay, we see our train and test data. So now we have created a data frame showing our strongest features. We are seeing top 10 features here, but I would probably use top 5. And we can see that the most important features that we have to take into consideration when quoting policy amount are, first of all, driver active, meaning who actually drives the car, main person on a policy or additional driver. If the main driver is driving more, which means the policy will go up. Second, policy term. This tells us how long are they buying policy with us for. Longer the policy, the better. Named insured points. It's very important to take into consideration. The bigger the amount, the higher the premium. Driver counts. The bigger amount of the drivers, the higher the premium. Named insured marital status. I did find that married people tend to pay less. Okay, so then we're doing modeling for policy risk. Again, preparing the data, getting rid of the object, doing label encoders, transferring our objects to numbers, and looks like our data is correct. We're taking some of the main, the strongest features, and looks like that's this. We're selecting strong features and then using our random forest classifier to be able to answer the question yes or no. So our variable is, we want to try to know if the person is likely to file a claim, and this is our variable y. If not, the x is everything else besides claim status. So we are running our random forest classifier and feeding our models, checking our accuracy score, and it looks like it's 97, actually 98, which is really high. So we have to run our confusion metrics and see if it's a good score. Okay, so we can see that we have pretty good for zeros, but our one is not that great. So let's just the correct prediction is 2,633, and only 56 prediction are wrong. So let's just run logistic regression and see if it's going to give us a better result. So we're running our logistic regression. The score is pretty similar. Doing our confusion matrix and classification report, and we can see that it's a little bit worse, to be honest. If you can see. because it gives us a little bit better results in the random forest. So by looking our original data, random forest and logistic regression, we can see that both logistic regression and random forest giving us 98% accuracy, but we will select random forest just because it has less type 2 error, which is really good.